Discussion 5.2 is an application of what we were looking at in 5.1 with the conversions between moles and grams and atoms. In discussion 5.2, we're going to be looking at percent composition and percent by mass, their similarities and their differences, as well as empirical formulas and molecular formulas. This is very similar to what you should have already done in Discovery 5.2, and in Discovery 5.2 it gave you the formulas for the percent problems as well as the steps to go through for finding empirical and molecular formulas. So to start, we have percent composition and percent by mass or mass percent questions. This tells us how much each element contributes to the total mass of the compound. An everyday example that you're used to seeing is your nutrition labels. You see when you're looking at calories or carbs, you see the percent of the daily value. It's very similar to that. To find it, you use percent equals mass of one of the elements, and something to make sure you take into account is it's the total mass of one of the elements over the mass of the entire compound, or the molar mass. And then whenever you're looking at percents, you multiply it by 100. And so there's two types of questions. Both use this formula. The first type of question is just find the percent composition. When you have questions that say find the percent composition, you're going to find both of the elements. When you have a question that says find the mass percent, you'll say find the mass percent of copper or find the mass percent of iron. When it says find the mass percent of an element, you find it of just that element. It's done the same way, but you just need to pay special attention to the wording. So as an example, example 1 says find the percent composition of N2O4. So when it says find the percent composition, that means we're going to find of both the N and the O. So what I like to do is along the side, make myself a note that I need to find both. So what we have to do first is figure out how much nitrogen is in the compound. And what you can do is say, well, I have 2 nitrogen atoms, 2 times the mass of a single nitrogen, which you can find on the periodic table, divided by the mass of the entire compound. Well, lucky for you, I already gave that to you, but you guys now know how to find it. So we're going to take 2 times the mass of 1 nitrogen, divide it by 92, multiply it by 100, and you get 30.5%. Do the same thing for O. So we have 4 oxygens times 16 divided by 92 times 100, 69.6%. They should almost equal 100. Sometimes rounding can make it a little bit different, but these would be your answers. So again, if we look at our final answers, we have 30.5% nitrogen, 69.6% oxygen. That is our percent composition. We found the percent composition of the compound, so we looked at each of the individual elements. Now if we look at example 2, it says find the mass percent of oxygen. That means I'm going to go about it the same way, except all I need to find now is oxygen. When we look to find the mass percent of oxygen, like I said before, we go about it the same way. So what I need to do is look in calcium nitrate how many oxygens I have. If you remember what we did before, this 2 gets distributed. So we have 2 times N, 2 times O3. So we end up having 6 oxygens times the mass divided by, again, the molar mass. Well, again, look how nice I am. I gave it to you, 164. Whenever you do anything with percentages, multiply it by 100. So if you plug this into your calculator, you should find that calcium nitrate is 58.5% oxygen. And it is important, I know we'll have a lot of people that ask this question, to have this O after. Okay, to have the O after is going to be very important. And that is all that we do for percent composition or mass percent types of problems. So the next application that we're going to look at is the empirical formula of a compound. The empirical formula is a simplest whole number ratio of elements. Very, very important that it's whole number ratio. It's essentially a basic ratio. If you think about cooking or baking, if you make cookies, you might need 1 cup of milk and 2 cups of flour. That is a ratio. So when we find the empirical formula, these steps will be extremely important. If you did the discovery, you should already have these written in. If you haven't looked at part C yet, these steps are actually on the sheet already, and you can write it into your composition notebook. Down here, this is not on the sheet, so you might want to add that to your notes. So what you have to do is first find the moles. Typically you're going to be given grams. Go to moles. You always compare the moles. Then identify the smallest number. Okay, because we need this to be a ratio, you're going to find the smallest number and divide all of your numbers by that one. And then you're going to either round up or down or multiply to get whole numbers. So if you get something like 1.5, 2.5, in order to make that a whole number, you multiply by 2. If you have something like 1.33, you multiply by 3. Okay, keep a lot of significant figures in order to help with your calculation. So, an example, we'll just jump in. I'll do an example for you, and then you can do one of the examples and check your answers. So this example says, find the empirical formula of a compound containing 10.52 grams of nickel, 4.38 grams of carbon, and 5.10 grams of nitrogen. So if you look at those steps, the first thing you have to do, convert to moles. So I'm going to take each one, and again, I like to write my elements down the side. It just helps keep everything in line. So for nickel, I have 10.52 grams. For carbon, I have 4.38 grams. And for nitrogen, I have 5.10. If you ever have any questions on what anything in here says, just ask me when you get to class, because the stylus doesn't write very well. So we need to convert to moles. Think back how we convert to moles. Well, we're going from grams to moles for each of these. Okay, so since we're going from grams to moles, we need the molar mass. So you need to look on the periodic table for each element, because each element has a different molar mass. So nickel, for every 1 mole, 58.69 grams. Carbon, for every 1 mole, 12.01. And for nitrogen, for every 1 mole, it's 14.01. So then, calculate this, and we find 0.179 moles, 0.365, and 0.364. So we converted to moles. That's the first thing. Now we need to figure out what's the smallest number. Well, think back to math. Smallest number is this 0.179. So divide all of them by 0.179. So you get 1, you get 2, and you get 2. And you should always have one of them when you divide. One of your elements should be equal to 1. So now, way that we write this empirical formula, we have nickel, just one of them. Carbon, we have 2 of them. Nitrogen, 2 of them. This is your empirical formula. So what I want you guys to do is try example 4. When you have anything that has percents, like you see here, just assume that's grams. So cross out the percent sign and put a G for grams. Okay, so if you try this one, I'm going to go through the steps, try it, pause the video right now, and then see if you get the same answer. So you should get C2H3O2. If not, ask. This is one where you have to multiply by 2. So we looked at the empirical formula. That is the simplest whole number ratio of elements in a compound. However, we normally use molecular formulas. Okay, molecular formula is the actual formula. This is what's helpful for us. It is a multiple of the empirical. Okay, so for an example, if CH4 was our empirical formula, Okay, notice it's simplest whole number. We have 1 carbon, 4 hydrogens. Well, then we could have either C2H8 or C3H12. Notice this one is just the empirical formula multiplied by 2. This one's the empirical multiplied by 3. Okay, so we just had to multiply. So in order to find the molecular formula, okay, first thing you need to do is find the empirical. If you don't already have the empirical formula, you need to find that. But then just divide the molar mass of the compound. So I'll always give you the molar mass of your molecular formula. You divide that by the molar mass of the empirical. See how much bigger it is, right? If it's, in this case, 2 times bigger, you're going to multiply your subscripts by 2. If it's 3 times bigger, multiply your subscripts by 3. That is what you do for a molecular formula. And so, with this example, I just said to find the molecular formula of an anti-cancer drug. Its empirical formula is C3H6N2. Okay, this is its simplest whole number ratio. But the molar mass of the overall compound is 210 grams per mole. Okay, so what we need to do is figure out what's my molar mass of my empirical formula. Well, if you go through like we did before, 3 carbons, 6 hydrogens, 2 nitrogens, you end up finding the molar mass of the empirical is 70 grams per mole. So what you need to do is figure out how much bigger is my molecular molar mass. Well, 210 divided by 70, it's 3 times bigger. What that means is multiply your empirical by 3. So we get C9, H18, N6. That is now your molecular formula, and this is actually how they go through and find formulas for something like anti-cancer drugs or any type of disease medications. This is actually how they come up with molecular formulas. So what I want you to do now is pause the video and go through this example. It says the analysis of rocket fuel showed that it contained 87.4% nitrogen and 12.6% hydrogen. The molar mass of the molecular compound is 32.05 grams per mole. What is the molecular formula? So this is one where, again, when you're given percents, cross it out and put grams. And now you guys first need to find the empirical, then go through and find the molecular. So go ahead, try this, and you pause the video, and then you can come back and check your answers and see if you get the same thing. Okay, so if you go through, find the empirical formula, find the molar mass of that, and then compare empirical to molecular, you find that the molecular formula is N2H4. Notice it is simply a multiple of your empirical. And that is all this discussion is on. This is a very math-heavy section. If you need to rewind and rewatch any examples, you can, but this should help you in solving any of these types of problems.